A slab of ice the size of the state of Florida is holding the ocean back. That's not a metaphor. It's literally what's happening right now as you watch this video. The Thwaites Glacier in West Antarctica spans 192,000 square kilometers. On its own, it accounts for roughly 4% of all sea level rise ever recorded on the planet. And for decades, scientists believed they had time. Decades to study it, decades to model it, decades to understand exactly how long remained before something irreversible happened. In 2023, they found out they were wrong. Not a little wrong, fundamentally wrong. Let me give you a number that changed everything. 14 kilometers. That's how far Thwaites' grounding line, the edge where the ice still touches the ocean floor, retreated in just under 6 months during the Antarctic winter of 2021. A rate twice as fast as any climate model had predicted for that period. And the grounding line is everything. It's the last point of physical contact between the glacier and solid ground. When it disappears, the ice begins to float, and floating ice melts in ways that anchored ice never can. To understand why this is happening now, you need to understand how Thwaites works, because it's not an ordinary glacier. Most glaciers rest on land that sits above sea level. Thwaites doesn't. The bedrock beneath it slopes downward as you move toward the interior of the continent, reaching more than 2,000 meters below sea level in its deepest sections. This makes it what glaciologists call a marine-based glacier, and that creates a feedback problem with no precedent in the last 10,000 years. When the ocean warms, and the Southern Ocean has warmed by 1.5 degrees Celsius in the 1980s, which may sound small but is enormous on an oceanic scale, warm water seeps in beneath the glacier. It melts the ice from below, weakens the contact point with the seabed, and the grounding line retreats. As it retreats, more ice surface becomes exposed to warm water. And as more ice becomes exposed, the process accelerates. It's a cycle that feeds on itself, and there is no off switch. In 2019, an international team of scientists from the ITGC, the International Thwaites Glacier Collaboration, managed for the first time to precisely map what is happening beneath the glacier. They used an autonomous underwater vehicle called RAN, remotely operated beneath the ice, to collect data that no satellite can capture. What they found was described by one of the researchers as the most disturbing thing I have ever seen in 30 years of polar science. A cavity, a massive melt cavity, 48 kilometers long and 300 meters tall at certain points, large enough to fit the Empire State Building inside with room to spare. It formed within the last few years. Previously, models assumed that melting occurred in a relatively uniform manner, but the cavity revealed that it's happening chaotically, at specific points where warm water currents penetrate deeper. Worse, where the cavity exists, ice is melting 2.5 times faster than the surrounding edges, and the cavity is growing. This matters for a specific reason. Ice melted from below creates air pockets that destabilize the layers above. It's the same principle as a structure with a corroded foundation. From the outside, it may look intact. On the inside, it's hollow. Before we continue, because the next part of this story is where things get truly serious. If you haven't subscribed to the channel yet, do it now. Every week features a different place, a different crisis, a different science that most people will never know existed. Red button right down there. Takes 2 seconds. The scientific community didn't stand still. Since 2018, the ITGC project has brought together more than 50 researchers from 8 countries in a $25 million effort, specifically aimed at understanding Thwaites. Field campaigns in Antarctica at temperatures of 40 degrees Celsius. Drilling probes that punch through 600 meters of ice to collect liquid water from below. Computational models running on supercomputers for weeks to simulate ice behavior over the next 50 years. And every time the models grow more sophisticated, the forecast grows darker. In 2021, a study published in the journal Nature Geoscience compared field data with projections from the IPCC, the UN's climate panel. The conclusion: previous projections had underestimated the rate of collapse by at least 40%. The reason was precisely the cavity. The older models assumed a melt geometry that simply doesn't match reality. There is also a proposal that has been circulating among engineers for years. installing underwater curtains along the glacier's edge to block the passage of warm water. A Norwegian company, Nordic Geosolutions, even conducted feasibility studies. The problem? To cover the full extent of Thwaites, it would be necessary to produce and install more than 100 kilometers of curtains at depths of up to 600 meters in the most inhospitable ocean on the planet, with logistics that would make the construction of the International Space Station look straightforward. The estimated cost, between $40 and $50 billion, and even then, it would only work if installed before the grounding line retreated past a critical point that, according to the most recent data, may already have been crossed. Here I need to pause for a moment because there's something about this story that deeply unsettles me, and it's probably not what you're thinking. What unsettles me isn't the collapse itself. Glaciers have collapsed before. Sea levels have risen and fallen throughout all of Earth's history. The planet has survived far worse. What unsettles me is the timing. The Thwaites Glacier has existed for at least 200,000 years. It has endured entire ice ages, periods of natural warming, orbital shifts that altered the planet's climate for millennia. It remained stable throughout all of that. And then, within roughly 80 years of heavy industrialization, a fraction of a second on the geological timescale, it began to break apart in a way that may be irreversible. There's no way not to feel the weight of that. The glacier doesn't know you exist. It isn't reacting to anything. It's simply following physics. But the physics is unfolding because the CO2 molecules your civilization pumped into the atmosphere are warming the ocean that is melting the ice that will raise the sea level that will flood the cities we built assuming the world would remain as it was, cause and effect. Simple as that. Here is what the most recent models say, without softening. If Thwaites' grounding line collapses completely, which 2023 data suggests could happen in decades, not centuries, the ice behind it, held in place by it, would lose its counterweight. And behind Thwaites lies the West Antarctic ice sheet, a mass of ice that, if destabilized, could raise global sea levels by up to 3.4 meters, 3 meters and 40 centimeters. To put that in perspective, Miami Beach sits 1.2 meters above current sea level, Bangkok 1.5 meters, parts of Mumbai less than 1 meter. Dhaka, home to 8 million people, is largely below 4 meters of elevation. And we're not just talking about coastal flooding. We're talking about shifts in ocean salinity patterns that affect currents like the AMOC, the Atlantic Meridional Overturning Circulation, which regulates the climate of Western Europe. The collapse of Thwaites is not a story about glaciers. It's a story about cascading effects. And the most frustrating aspect of all this science is that there exists a point of no return, a threshold beyond which, even if we were to immediately halt every emission on the planet, the process would continue on its own through physical momentum. Scientists debate exactly where that point lies, but most agree it is not far off. Some believe we have already passed it. Thwaites is not the end of the world, but it is one of the clearest indicators we have that the world we know is changing in ways we cannot simply wait and see. The data exists. The physics is clear. What is not clear is how civilization will respond, or whether it will respond fast enough. If you want to keep exploring the places where the Earth is telling us something urgent, subscribe to the channel. Every week it's a different environment, a different system, a different frontier between what we know and what we are only beginning to understand. And now I want to hear from you. Do you think large-scale geoengineering, like the underwater curtains I mentioned, is something humanity should attempt, even without any guarantee it will work? Or is that interfering too much with a system we've already pushed too far? Write it in the comments. Seriously, I want to read them.